Once we have this sort of point on the terminal side, the xy plane set up, we can actually sort of use this to find some trig values. So let's run a few examples. So find all trig values for angle theta where point equals, so we'll keep our numbers kind of semi-reasonable. Let's do -2, 3. So on the terminal side. So our point is -2, 3. First and foremost, let's just figure out, so just mentally, which quadrant are we in? So this is a -x and a positive y. So back and then up. So that's going to be quadrant 2. So what I like to do is just make a little bit of a sketch. This isn't necessary. We kind of know, right, the x coordinate should sync up with the adjacent side, the y should sync up with the opposite, and then we can sort of find our value. But, you know, humor me for a minute. Let's just sort of take a second. So -2 and then up 3. So our point P is here. So our angle is this kind of exterior angle. What we're sort of working with then to sort of draw our triangle straight down, we're using our sort of reference angle as the internal angle here. So we've got x is -2. That's going to be our adjacent, right? The y value is +3. That's going to be our opposite. And then we got to figure out our hypotenuse. So let's find r, which is our hypotenuse. So the idea, right, is that x squared plus y squared is r squared. This is just classic Pythagorean theorem stuff. What happens, right? We have a negative value for x, but when you square the negative, it's just going to become a positive, right? So this is just going to be 4 plus 9. So 13 is r squared. In theory, right, if we're starting to introduce positives or negatives, right, does this mean that, like, the value for r could be, like, positive or -13? In some sense, like, yeah, I don't know, maybe. But for us to sort of, you know, make sense of this and have it be consistent, we're talking about specifically, right, a negative direction. This sort of r value is really just a length that's diagonal to the axes. So we're just going to think of it as a positive. So our radius values here are going to be positives no matter what. It looks like it's going to be root 13. So let's just run these, run these down pretty fast, right? Sine, cosine, tangent, and then we'll flip them to get our reciprocals. So sine theta, so this should be the y value divided by the r. So that's going to be 3 over root 13. Got to rationalize, right? So we'll do root in the root. So this is 3 root 13 over 13. Let's just do the, we'll just flip it while we're here, right? Cosecant, our reciprocal, right? So that would be the radius over y. And let's just flip this early version, right, before we rationalized. We'll just sort of get our root on top, just sort of nice and fast. Save us a little trouble. Cosine theta, so that's our adjacent over the hypotenuse, so that's going to be the x value over the radius. That one uses our negative, right? -2 over the root. Same thing, we have to rationalize. So cosine in this position is going to get us a negative result, right? Because the x value is a part of it, and our x value in that quadrant is going to be negative. If cosine is negative, then secant, if we flip it, is also going to be negative, right? So we just flip this original version, r over the x, so we'll just get root 13 over -2. We'll just call that negative root 13 over 2. In theory, right, sure, the negative is like coming from the denominator value, but the whole thing is negative. It doesn't particularly make a big difference. Last two, tangent. So that's the y over the x. X's and the Y's here are actually just whole numbers, right? So that's going to be 3 over minus 2, negative 3 halves. No roots, so that's nice. Cotangent will flip it. X over the Y, so negative 2/3. So finding these guys is pretty fast. I like the picture. I kind of always like being able to sort of go back and have that right triangle as a visual reference. That I find helpful. So much of the trig that we do, you can kind of tie back to that original opposite over hypotenuse, like those types of setups. So I kind of like to refer back to that. In theory, you could just do this kind of algebra style, just like from our setups, just find the R first and then go. But I like the picture. I like drawing another picture. Why not? Let's do another example. Let's do quadrant 3. That was kind of interesting because both the X and the Y values would be negative. We'll sort of try to keep the size of the numbers down. So evaluate all of our trig functions. Theta, where our point, so let's do negative 4 comma negative 1 is on the terminal side. So negative 4, negative 1. Same thing. Let's give ourselves a little sketch. I'll scoot this up so we got a little bit more room. So this is going to be, I kind of promised quad 3, right? Because this is going to be x negative, y negative. Going to draw it accordingly. So what is this? Negative 4 in the x. 1, 2, 3, 4. Negative 1 in the y. So that's kind of a short one. So a little bit of a shallow angle. Theta, right, goes all the way through. And if we drew our triangle, going like this, right angle is here. So this is negative 1. This guy's negative 4. We'll find the R value, which is our hypotenuse. And then our reference angle, right, our sort of theta prime, theta with the apostrophe is in there. So let's do our radius first. R squared should be x squared plus y squared. So R squared is going to be negative 4 squared plus negative 1 squared, 16 plus 1, so that would be 17. So if R squared is 17, that must mean that the radius itself is just the root 17. Again, we're not trying to do a is it positive, is it negative? We're not trying to be ambiguous about it. We just are going to get a positive value here for the radius. We're only getting positive or negative aspects from the x and the y. So that's going to be root 17. Right, our opposite here, our adjacent is here. So we can just run all these trig functions down. Let's do it. We'll go kind of in the same order we did before, I suppose. So sine theta, so that's the y value over the r. So that's for us going to be what? Negative 1 over the root. One of the things here that's a little unfortunate is if we're sort of starting with, the probably natural tendency is going to be to make your x's and y's whole numbers, which means if you get a root, it's very likely to be the hypotenuse. So you're kind of starting off with a little bit of like rationalization. So this would be negative root 17 over 17, right, times the negative 1. Cosecant, if we just flip that over, radius over y, so that's just going to be root 17 over negative 1, negative root 17. Good to go. Cosine theta, x over r, my x now is my negative 4. A similar kind of pattern, right, over the root. We're sort of starting to see these enough that this pattern becomes pretty clear. We'll, of course, keep putting the full workout here for our notes, but we kind of know we're going to expect negative 4 root 17 over 17. We'll flip it. We'll flip it from the earlier version to get our secant. So the radius over x, so that's going to be negative version root 17 over 4. And I'll sneak this up just a little bit. We'll squeeze tangent and cotangent in underneath. I tried to have this nice and lined up and it just didn't work. That's okay. Tangent theta, so y over x, these are a little faster because again both of these are based on the whole numbers. So for us this is going to be what? Negative 1 over negative 4. Now that's double negatives, so our tangent actually, right, the negatives cancel out, we just get a positive 1/4. Same kind of thing for cotangent, right? So that's going to be the x value over the y. So that's going to be negative 4 over negative 1. Negative cancels negative, and we just get positive 4. So we can start to see some patterns here a little bit if we think of this in terms of the x and y values and what their sort of positive or negative sign is. You can kind of start to get some associations with the positive or negative sign of your trig functions, right? The sine function is going to be sort of positive or negative relative to the y coordinate. The cosine function will be positive or negative relative to the x coordinate. And then tangent kind of depends because tangent is sort of a mix of the two. The next thing we're going to do is try to generalize that a little bit, get some patterns going across all 4 quadrants. So that'll be next.